This video is on parallel and perpendicular lines. Parallel means to have the same slope. So if we're going in perpendicular, means to have opposite reciprocal slopes. So if we're going to use a graph to find a parallel line of another line through a given point, we can do this graphically very simply. So if we're given an equation, or we're given the graph of an original line, and we want the parallel line through a different point, we do these steps. First, we graph or plot the given point. So whatever they tell you, graph or plot the given point. Then, we're going to use the parallel, which is the same slope, to graph the rest of the line. Now we're going to use that pattern so that we can find the new y-intercept. Once we find the new y-intercept, we have the slope and the new y-intercept, so we can write the equation. But we have to make sure we write the new equation with the correct slope and the new y-intercept. This is through a graph. We can also do this if you cannot find the new y-intercept because it is a fraction or a decimal and you can't see it clearly on the graph. You can do it algebraically, which will be done in a separate video. So for an example, we're going to write the equation of the line that is parallel to y equals 1/3 x minus 4, but goes through the point -6, 4. So let's graph the original line. So we have x and y. We're going to count by ones. So the original line, we have our y-intercept of -4, of 0, -4. So we go down to 0, -4. We have a slope of 1/3. So that's a change in y of 1 and a change of x of 3. So 1 and the change in y, and then 1, 2, 3 is the change of x. Do this as much as you can. And then go the opposite way. So change in y of -1, change of x of -3. Change in y, change in x. Change in y, change in x. So we're going to graph this line. Going to have that with arrows on it. Don't know why that didn't. It's supposed to have arrows on it. I'm not really sure why it doesn't. There it goes. So we have our original line. So we want to graph the line or write the equation that is parallel to this line, but going through this coordinate. So let's get our actual slope. Our parallel slope has to be the same slope. So we have a 1/3. So our slope would be 1/3. So our parallel slope is the same, so it will also be 1/3. We have the coordinate of -6, 4. So let's go to that coordinate. -6, 4. Now we're going to use our slope to see if we can get to our y-intercept. So we're going to use that same slope of change in y of 1, change of x of +3. And we actually do get to our y-intercept. I'm going to keep going though so I can graph the rest of the line. I want to graph the entire line as much as possible. And so now I'm going to graph the line. I'm going to change this color to pink. Guess that's the color I'm going to change it to. That is not pink. Okay, so that should have arrows on it. That should have arrows. I'm going to change that to arrows. Okay, so our new y-intercept is right here. That's at 0, 1, 2, 3, 4, 5, 6. It's at 0, 6. Now that we have the parallel slope and the new y-intercept, we can write our equation as y equals, so our equation is y equals 1/3 x, and then our constant is positive 6. This is our new equation. Because we have the parallel slope, and we can find the new y-intercept using the graph. We can do the same thing with perpendicular slopes as well. So again, for perpendicular slopes, we have opposite reciprocal slopes. So we have one line that has a slope of -1/2 and one line that has a slope of +2. One's positive, one's negative, and the other is reciprocal when you flip the fraction. You'll see perpendicular with the box in the corner. So we're going to do the same thing. We're going to graph or plot the given point. We're going to use the perpendicular, which is opposite reciprocal slope, to graph the rest of the line. We're then going to find the new y-intercept. And then we're going to write the equation, but using with the correct slope, making sure we're knowing which slope we're going to use, and the new y-intercept. So for this example, we're going to, again, we can also find the equation of the line through a given point mathematically, which will be done in a separate video. So we're going to write the equation of the line that is perpendicular to y equals 3/2 x plus 7, but goes through the point 3, -4. So let's do our original graph. So we have x, y. We're going to count by 1, because we don't want to write out 1, 2, 3 all the way down. So our first coordinate is going to be 0, 7 to be our y-intercept, our original y-intercept. And our slope is 3/2, so change in y of 3, change in x of 2. This is as far as I can go on that side. So I'm going to do -3 over -2. And I'll keep going. One, 2, 3, 1, 2. So now I'll have this line with arrows on them. So now I want to write the equation. I'm going to graph the equation that's perpendicular to this line, but going through this coordinate. So the slope, the original slope, is equal to 3/2. So our perpendicular slope which I'll write as m and then our perpendicular symbol, is equal to, we have to do the opposite, so it was positive, so now it's negative. We need to flip our fraction to be the reciprocal, so it should be -2/3. So that's our slope. We want to find our new y-intercept. So we want to go to the coordinate 3, -4. And we want to use our slope of -2/3 to do the rest of the line. So change in y of -2, change in x of +3. Can't go any further here, so I'll do a change of y of +2 and a change of x of -3. This is as far as I can go, so I'll draw my line here. And then I look for my new y-intercept, which in this case we have right here. So our new y-intercept is at coordinate 0, -2. So now that we have our new y-intercept, we can write our equation. which is y equals, so our slope that we have to use because it's perpendicular is negative 2/3 x, and our new y-intercept is at negative 2, so what the constant is minus 2. This is our new equation, where this is the equation that is perpendicular to y equals 3/2 x plus 7 and goes through the coordinate of 3, negative 4. So this, again, is how we can do it with graphing, and if you can easily find your new y-intercept. If your new y-intercept is not easily discernible, you can do it algebraically, and that's in another video.